electricity consumption optimization using Cambridge clustering algorithm. 현황 챕터장 17-71016. Advisor Dr. Dongnyeoshin, co-advisor Dr. Mohammad Fresh Crash, and Sungwon University, South Korea. Outline. Introduction. Related work. Proposed approach. Analysis of electricity consumption at home through a serious core perspective. Analysis of electrical consumption at home using Cambridge clustering algorithm. Evaluation. Electricity consumption at home analysis. Cambridge clustering analysis. Conclusion and references. Introduction. Electricity consumption. Power grid. In the power grid, we measure the consumption through sensors, industrial consumption, housing consumption, factories consumption, housing consumption, front-end, consumer end, back-end, electrical component. Introduction continues. Back-end, component, data set from consumption, University of California, Irvine. So many techniques that solve the optimization problem of electricity, but none of them focus on housing electricity optimization. Reducing the cost, factors of overcharge prediction are not available now. Introduction continues. Solution. K-means algorithm. Why choose K-means cluster? Predict the answer from the dataset. Though any answer is available in terms of K-means. Why predicting the answers? No clear result. In this paper, electrical usage of home is analyzed through K-means clustering algorithm for obtaining the optimal home usage. Electrical usage of home is 3A is analyzed through K-means clustering algorithm for obtaining the optimal home usage electricity data point, the current calibration index, Dave's burden index, and serial score. Find details optimal number of clusters in the K-means algorithm and present the application scenario of machine learning algorithm. 3B is reducing the A1 dataset and result the same result. The proposed approach delivers us efficient and meaning prediction result never obtained before. Related work, machine learning, a way to run machine with the dataset values, reference 1, several ways such as reference 2, 3, and 4. K-means clustering, one of the methods for the machine learning algorithm under the machine learning category, reference 5th. It is a main task of exploratory data mining and a common technique for statistical analysis and used in many fields, reference 6, 7, and 8. Community feasibility assessment, community analysis is not one specific algorithm. What constitutes a cluster and how to efficiently find them? The notion of clusters include groups with small distances between cluster members, dense areas of data spaces. Reference 9, 10, and 11. Related work continues. Classification is a process related to categorization, the process in which ideas and objects are recognized, differentiated, and understood. Reference 12, 13, and 14. Supervised learning. Supervised learning is a machine learning task of learning a function that maps an input to an output based on example input-output pairs. It infers a function from labeled training data consisting of a set of training examples. Lessons 15, 16, and 17. Unsupervised learning. Too many approaches to solve the problem, such as in clustering, K-means mixture models, DB-scan, optics algorithm. Reference 18, 19, and 20. Index from the unsupervised learning need how to efficiently find them. Popular notion of clusters include a group with small distances between cluster members, dense areas of data space, such as current calibration index, serial score, Dave's burden index, reference 21. Related work continues. Scikit-learn, one of the machine learning library from the 2007 till 2019 continuously update the version of the library. Reference 12.2. Machine learning repository overview. UC Urban Machine Learning Repository. Individual household electrical power consumption dataset. Reference 23. Dataset parameters. First, date. Second, time. Third, global active power. Fourth, global reactive power. Fifth, global voltage. Sixth, global intensity. Seventh, submetering 1. Eighth, submetering 2. Ninth, submetering 3. Definition of dataset. Household power consumption from the dataset downloaded from the University of California Irvine Machine Learning Dataset Repository. Reference 8. And then use it. In this dataset via the limiter is divided. Global active power, global reactive power, voltage, global intensity is divided. Global active power and global reactive power XY axis experimented. Proposed approach A. Analysis of electrical consumption at home through a serial score perspective. Serial score. Serial score is an easy way to in data I each data cluster in data's definition and I each data is not clustered in and data's definition BI serial score SI is equal to calculated SI equal max AI BI minus AI. From this calculate SI is equal to the function minus 1 SI 1. SI is the close to 1 is the data each data I is the correct clusters to each thing. Close to -1 cannot distribute cluster is distributed. From this paper, machine using the machine learning library scikit-learn is household power consumption clustering. Reference 23, 24, and 25. Analysis of electrical consumption at home through a Schiller score perspective continues. Current carbon index. How to be where to be clustering in a way is current carbon index, Dave's burden index, Dunn index. Schiller score in this paper evaluated via current carbon index and Schiller score evaluated from the current carbon index. The clusters distributed average and cluster distributed ratio will give it to you. SK, TR, WK, TR, BK, K-1 per M-K. For this, BK is distributed matrix from the each group. WK is a cluster distributed defined. Reference 26, 27, and 28. WK equals sigma Q equal 1, x minus CQ, x minus CQT. BK sigma Q and Q CQ minus CQ minus T. Analysis of electrical consumption at home through a Schiller score perspective continues. Dave's burden index. If the ground truth rates are not known, the Dave's burden index sklearn matrix Dave's burden Rij Si plus Sj Dij, then the Dave's burden index is defined as dB equal I sigma k. Sigma I k makes I not j. Rij, the zero is the lowest score of possible score. Value closer to zero indicate a better partition. But the problem is, in this algorithm, do not teach it in the scikit-learn library and only explain it in the document page, but cannot explain it easily. Reference 29, 13, and 31. Proposed approach B. Analysis of electric consumption at home using k-means clustering algorithm, reducing the dataset. Paper 1 dataset for this archive contains 2075 259 measurements gathered in a house located in sequence 7 kilometers of Paris, France, between December 26 and November 2010. 47 months. This is a fit the same result. Labeled data from machine learning library already clearly cleansing for the dataset. Evaluation, declaration, and resources. System PC configuration software. A execution snapshot. B execution snapshot. Analysis A. This is the optimal result for the experiment. K equals 7th result. From the k-means algorithm, calculate the proper cluster scene is very important. From the data estimated serial score, the result is k equals 7. Cluster centroid and data prices serial score are 0.799 is the optimal score. From the former current carbon index, result are 560.3999 is the optimal result. Using this k-means algorithm, the factor is figured. Analysis A continues, but the problem is this algorithm do not teach it in the scikit-learn library and only explained in the document page but cannot explain it easily. Analysis B. This is the optimal result for the A/1 dataset for the k-means clustering. Serial score according to the change of cluster member. A/1 dataset serial score according to change of cluster member. From k-means algorithms, cluster proper processing is very important. From the data estimated serial score, the result is k equals 7. The result is each cluster centroid and data prices. Serial score is 0.799 is the optimal score. Even if data sets are small, but the A/1 dataset k equals 7, each cluster centroid and data prices, serial score is 0.1, 0.810 is the optimal score. From this came the algorithm cluster 7. All dataset A/1 dataset, each grows centroid, and each centroid distances will be an optimal value. From this result, the dataset decreases, but the k-means clustering class vector spaces. Its optimal cluster is the same situation with before. Original dataset household power consumption rate via clustering. Evaluation A execution snapshot. K equals 7 among the result, K equals 7 result is optimal result for this experiment. Evaluation B execution snapshot. A/1 dataset for k equals 7 result is among the all about this experiment for the best result and optimal result for this experiment. Software and workstation environment. PC performance. Software. ARM3 plus JetBrains software. PyCharm. OS software. Windows 10 Professional. RAM 60GB. Processor i7 6600 UCPU 2.160 GHz. Hard disk 420GB SSD. System PC configuration software. Dataset used by machine learning dataset. Scikit-learn ARM3. PyCharm. Scikit-learn open. Scikit-learn is open source. ARM3 is also there's an arpanda.com and you can download from the academic version of the ARM3. PyCharm is JetBrains software and then you can put the you can download the academic version of the PyCharm. If you do not using the original version and genuine version, and then you cannot see the optimal same result with before, and cannot get a clear result. Open source personally can easily follow it, and because using the BSC license to real world don't have difficulty to do that. Conclusion. Household power consumption via K-means clustering uses a library which is exactly known. Arcana 3. Open source person can easily follow it, and because using the BSC license to real worlds don't have difficulties to do that. Not only the K-means algorithm, PCA algorithms, but also SVM algorithms, etc. Other machine learning algorithms clusters can also do it. From this result, in real life, household power consumptions, diverse analytics, and the electric transformer transmission power can management period can be estimated, and each data using its electricity consumption, it can be used for progress station, regional to regional demand forecasting, maintenance of power plant and facilities can do it. In the gas company, Seoul Gas, Google TensorFlow meter of second 2017 can estimate via K-means algorithms and also can estimate about the gas consumption rate to via K-means clustering and index. Published paper, 현웅진, 나 Muhammad Fekish and Dong-Yushin. Comparative analysis of electrical consumption at home through a telescope perspective. ICC 2019, South Korea. 2019, Sungwon News, Korea. 현웅진, 나 Muhammad Fekish and Dong-Yushin. Analysis of electrical consumption at home using K-means clustering algorithm. ICC 2019, South Korea. 2019, Sungwon University, Korea. Acknowledgement. Dr. Dong-Yushin, President of Sungwon University, currently May 14, 2019. Co-advisor Dr. Muhammad Fekish, Assistant Professor. First joined the SKKU Mobile Computing Laboratory. Professor Hee Young-Min, SKKU Fellow. Advising for pre-defense Dr. Narvati Sixna Professor. First joined the OpenLab Dr. Chun Sang-na. Google TensorFlow Meetup Second 2017 Conferences. Seoul Gas. OpenLab member. Currently May 14, 2019. Dr. Gian Chun, Muhammad Hamza, and Janet. Woo Hyung Kim and So Cho. POSCO ESG, Chat Duty Manager, Cooperative Partner, LG Electronics, LG CNS, LG U+, 명성로 MD PhD Professor. Acknowledgement. LG Electronics academic support, and then for the academic and tuition for the LG CNS, LG Electronics, LG U+ invite the conferences. POSCO ESG support the transportation support and night and return to my home and then transportation support from the employee. Google AI motivation from the conferences, then TensorFlow Meetups 2017. Korean Air supported the Monicom service and participated at the conference. When I relaxation time and the safe security and Incheon International Airport. Religious stress and volunteer works at the Assam Medical Center, and emergency room, and then all about the places. Samsung Eye Center and support the vision management, and then split support from the Myungji Hospital. References 1 to 10th result references, 11 to 12th, 20th references, 23rd to 13th references, 31 to 38th references. End of slide and Q&A.